Hi everyone, in this video segment we are going to be talking about electronegativity and its effect on acidity and basicity. Keep in mind, again, we're always making some comparison, so again, comparative thinking and ideas here. Higher electronegativity atoms in general possess more acidic hydrogens than atoms of lower electronegativity. This is because higher electronegativity atoms better accommodate the extra lone pair in the conjugate base once they have been deprotonated. And let's look at some examples. Here we have methane, CH4, NH3, H2O, and hydrofluoric acid, HF. I've indicated the atoms here. We're comparing acidic hydrogens bonded to carbon, nitrogen, oxygen, and fluorine going from left to right. I've also indicated approximate pKa values. So notice that HF, having the lowest pKa, is the most acidic. The least acidic acid in that series is methane, CH4, approximate pKa 49. Now we see increasing acidity going from left to right because we have increasing electronegativity of the atom that is directly bonded to the acidic proton. Again, a great way to compare relative acidity is to look at conjugate base stability. So here are the conjugate bases. CH4 is deprotonated to form CH3-. NH3 is deprotonated to form NH2-. H2O is deprotonated to form OH-. Lastly, HF is deprotonated to form F-. And when we think about higher electronegativity atoms, like fluorine is more accommodating of that negative charge than oxygen would be. If fluorine is more accommodating of that negative, it means it is more stable with that negative. F- is the most stable anion in this series. CH3- is the least stable anion. Why is it the least stable? Well, it's got the lowest electronegativity, so it doesn't stabilize that negative to the greatest extent. If this is the least stable anion, least stable, unstable equals strong. If this is the strongest base, then it has the weakest conjugate acid. If F- is the most stable, if it is the most stable, it is the weakest of the bases. If this is the weakest base, it corresponds then to the strongest acid in this series. Okay, that's essentially how you can use electronegativity. And again, electronegativity is a comparison that we'll use if we're looking at atoms that are in the same periodic row. If you go from left to right on the periodic table, you would see carbon, nitrogen, oxygen, and fluorine. Okay, so we will say electronegativity best distinguishes the difference in acidity between two acids when the two atoms, or here in a series, are atoms bearing the acidic proton are different and they're located in the same periodic row. Again, HF is the most acidic of these acids because it loses its proton to form its conjugate base, which is the most stable conjugate base in this series. A more stable conjugate base is a weaker base.